Hello and welcome. What we'll be doing here is we'll be solving an example of one of the three types of projectile motion that are typical that you'll see for this chapter. And this one is horizontally thrown projectile. Now, it must be noted that for a horizontally thrown projectile, what's special about this is that the initial velocity only has an x component. So this right here, its initial velocity is just a x component. What is its y component? Well, the y component is nada. It is 0. You can call it 0 meters per second, if you will. Okay? And I have up here the equations that we'll need. Not all of them, but we're going to use actually a couple of them for this problem. So let's start with first things first. Let's figure out what is given. So the plane is traveling horizontally at 40 meters per second. And it is 100 meters above the ground. And our goal actually is that. Okay? Now, one thing that I neglected to mention here is that you have to neglect air resistance. And hopefully by this time you already know the reason for that, because when you neglect air resistance, that means that you can use the concept of free fall. And when it's free fall, how much is acceleration due to gravity? Well, that would be, the magnitude at least, would be 9.8 meters per second squared. So that actually is one of your given right there. Okay, so what else are we given? Let's write that down. That 40 meters per second is actually your initial velocity, which already is your x component. And the 100 meters above the ground, if I'm stating this point as my origin, then guess what? Does it go up or down? So that becomes negative 100 meters because it's going which way? Down. And our goal is actually to find the delta x. And I'm going to tell you right now, to anyone listening to this video, is that another sub-goal, if you will, that you have to solve for the time. Okay? And that's all we're given besides the 9.8. Okay? So the two formulas that we'll need, I already know which formulas I need, are these, that one and this one. Now I personally like to change this into delta x and that to delta y. Okay, you'll see in a bit. I'm going to use the bottom one first and then go to the second one. Okay? I'll just write it down here. And this is the second one that we'll use. It's just that there's no acceleration part. Now this comes with a warning. So notice that this is already negative. Do not substitute in for g negative 9.8 because you'll get a negative here and there, and you get a double negative and you'll get the completely wrong answer. Okay? Just take note that if you're using it from the kinematics constant acceleration equation, then just keep that as a positive. Okay? Just a word of caution. Otherwise, just keep these equations as I've written them down here. Okay, so let's use the first one. And right off the bat, something cancels out to 0. Now what is that? It is because we said that this VIY is actually 0. There is no y component to that initial velocity. So that first term completely goes away. Okay, what are we left with? Wait, we have a negative there. Is that good or is that bad? So let's start solving for t. And let's multiply both sides by 2 over g. And that will actually cancel negative 2 over g, so that actually cancels all of that out. And I'm going to get 2 delta y for g t squared. Then I'm going to take the square root of both sides. Uh-oh. What did we just do? And I'm going to flip-a-rooney these two things, okay? So that becomes t. Now I have a square root of negative 2 delta y over g. Now how's that negative sign going to work? But take note, what is our displacement? Our vertical displacement actually is negative. So that was actually an important point that you have to remember. It should all work out because it's something physical. So when I substitute the actual number, it's negative 2, negative 100 meters. Sure enough, negative times negative would be a positive. And there you go. So that's going to be positive 200 on top. And take a look at the units. Add meters, meters on top here. And this second squared is actually going to go on top. So the units essentially are going to turn out to be square root of second squared, or seconds, which is exactly what our intermediary thing that we're solving for. So let me solve for that. And what we get there is a time of 4.517539. Let's just gonna write this. If you get rounding error, that's fine, but you still get something close to the answer. I encourage you to know the memory storage in your calculator, or just keep it handy on your calculator for now, because that is not the end yet. Okay, we're going to use the second equation now, that simple one, which what we were solving for to begin with, xt. And now we already know that that Vix is actually 40 meters per second, and there's a reason why I'm writing it like that, times the 4.52, or the non-terminating decimal that you have. That cancels out, and that leaves you with a unit of meters. So I'm just going to multiply what I have on my calculator, and sure enough, I get 180.7, but if I keep to 3 sig figs, then that is my answer. Okay, there you go. I apologize for all the mistakes in this video, but hopefully this will be helpful to you in preparation for the exams. Good luck and enjoy.